So hello everyone, we're sorry about the technical difficulties. We're going to try to make this work. This is our very first webinar and we're using Microsoft Teams Live for the first time for this. So I wanted to welcome you to the MD webinar series. We will be bringing different topics every month. Please reach out to us if you need any data analytics and AI consulting services. We are Microsoft certified partners. And you can follow us on your favorite social platform under Magna Data Inc. So let's try to get started. This is Cecilia Presentatory hosting, and for today, our presenter Barkha Herman is getting us started with Azure Databricks. Thank you very much, Barkha, and whenever you are ready, let's try to make this work.
So thank you very much for being here, and thank you for your patience while we figure out what's going on here. As Cecilia said, this is our very first presentation, so bear with us. We're trying to figure things out. My name is Barkha Herman. I'm a senior cloud solution architect specializing in data and AI. I work for Microsoft, and this section is an introduction to Databricks. So if that's not what you were expecting, you're in the wrong place. I'm going to start with just saying a couple things about me. I've lived in Florida for 30+ years, originally from India. I'm a coach, I'm a technologist, I'm a rock climber, and I'm a chef. And this is my beautiful family here. One of my favorite quotes, whether you think you can or you think you can't, you're right, Henry Ford. And here's some, fun stuff. Personality type stuff about me. And let's get to what we're going to be talking about today. So I added a slide on big data. I don't start with it, but I just wanted some clarity on it. So I added a slide on it. We're going to do just a few minutes of Spark overview before we get into Databricks, because Databricks is very much an add-on to Spark. And you'll see how. We're going to be doing a lot of demo today, okay? So a lot of demo, and I'm going to help you with some resources on how you can upscale on Databricks, and then finally we're going to be doing some question and answers. All right, so let's get started. So what is big data? I love this cartoon from Dilbert. Using it is the hardest part. So it's extremely large data sets that may be analyzed computationally to reveal patterns, trends, and associations, especially relating to human behavior and interaction. We're going to talk about a little bit of history. You will not be surprised to learn that the collection of big data started with internet, and of course, one of the first players in this space was Google, because they had so much data. They launched, MapReduce and introduced concepts like MapReduce and Hadoop. Hadoop was a Spark Apache Foundation project, but MapReduce was presented by Google. Anyone know what Hadoop is? I guess I'm going to carry on. So Apache Hadoop is the original big data solution. It's a collection of open source software utilities that facilitate using parallel processing, many computers, to solve big data issues. Okay. Moving on to Spark. So here's the timeline for Spark. Started in 2010 at UC Berkeley. Version 0.5 was released in 2012. Databricks, by the way, was launched in 2013, and they started to donate to the Apache Spark Foundation in 2013 as soon as they launched. And one of the reasons why is because Databricks was a company that was started by the original contributors, authors of the Apache Spark project. So very tightly woven there. 2014, Spark 1.0 was released, including things like Spark SQL, ML, and GraphX. And we'll cover this a little bit in future slides. 2015 was when they introduced data frames, ML pipelines, and Tungsten. 2016, Apache Spark 2.0, and 2018 was Apache Spark 3.0, which is the current release version. So let's look at Spark first before we move into Databricks, because Spark is the foundation for Databricks. Spark is a unified open source parallel data processing framework for big data analytics. What does that mean? So it's unified. It's a platform. So it has a Spark core engine, which is the light blue line that you see in the middle. And on top of it, it has other things such as Spark SQL. So you can do interactive queries using Spark. Spark ML-lib, which is machine learning part of Spark. Streaming, so stream processing. GraphX, which is graph computation. And it sits on top of Yarn, Mesos, and standalone scheduler. So Yarn for DevOps, deployment, Mesos for it's a layer between operating system and software. So that's what it's built on top of, and then it uses a scheduler. What does it unify? It unifies batch processing, interactive SQL, real-time processing, machine learning, deep learning, graph processing. You guys are asking questions. I can't see them, so I'm going to try and...
No, not yet.
Okay, good. Let's talk about the benefits of Spark. One of the differences between Hadoop and Spark is that Spark uses in-memory computing. So obviously in-memory is faster than reading from disk. So it can be up to 100 times faster than Hadoop. This is slightly old slide. I don't know if it's still as fast. So it can be used to batch real-time data processing. That's another thing that it does. Easy to use APIs for processing large data sets. Tons of, it's a very rich API infrastructure, so it's a very robust and mature product. Unified engine. So integrated framework includes high-level libraries for interactive SQL queries, as well as stream analytics, ML, and graph processing. So in one application, you can actually do all these things. So you have one API to learn, and you can interactively do all kinds of stuff. We'll be doing some demos on how this happens. And also, it's an ecosystem. So Spark has built-in support for many data sources. It has a rich ecosystem of ISV applications and a very large developer community. It's also available on pretty much every cloud, AWS, Google, Azure. And there's also on-premise distributors, so you can deploy it wherever. So advantages of a unified platform. So one of the things that Spark does is it does streaming. The way it does streaming is that it actually batches the streams. And so unlike if you guys are used to Storm, which actually does event processing just like Spark streaming does, but it does one event at a time, Spark streaming actually takes a batch of events and then it'll process So there's less of a queue built up because it's doing batch work. So streams of events is treated as batches and supports. Also supports machine learning. We'll go a little bit more into machine learning, all the different kinds of supports that it has. But you know, it supports all your usual suspects. It does, you know, it can train and learn and test and all kinds of stuff. And then Spark SQL is kind of neat because you can actually do interactive queries against Spark data. And it uses this concept called the resilient distributed data set as the basis of all interaction. So every Spark job starts with an RDD. So it's a fundamental data structure of Spark. It's an immutable collection of objects. And what happens is that the RDD is distributed to different compute nodes, and those are immutable, so those are processed in parallel. So each data set in Spark RDD is logically partitioned across many servers so that they can be computed on different nodes of the cluster. And we'll talk about what cluster is. Also supports NoSQL DB. Developers can mix and match different kinds of processing in the same application. And also performance improves because unnecessary movement of data across engines is eliminated. In many pipelines, data exchange between engines is the dominant cause. Okay.
There is a question. Can Spark be used for hacking?
So I don't know what that means, but if it is to process big data, the answer is yes, right? So if by hacking you think that you have, you know, a massive amount of data and you need to do something with it, then yes, sure. Now, the intention is up to you. Okay. Let's talk about Azure Databricks. So Databricks Spark as managed service on Azure. So Databricks was, as I mentioned before, was founded in late 2013. It was started by the creators of APACHE SPARK, the original team from UC Berkeley, AMP Lab. They are the largest code contributor to Apache Spark project. Okay, and they have 2/3 support partnership with level 2 or level 3 support partnership with Hortonworks, Map our data stacks. So they're a huge player in the open source space, and they do a lot of integrations with other companies that are also big players in the ML space, big data and ML space. They provide certifications such as Databricks Certified Application, Databricks Certified Distribution, and Databricks Certified Developer. So if you guys are interested in getting certifications related to this, those are available. And their main product is the Unified Analytics Platform. And also, they introduced in 2017 this thing called Databricks Delta, and we'll talk a little bit about that as well. So Databricks runtime powered by Apache Spark, and then you can see what it does: cross-team collaboration, production workflows, and cloud infrastructure. On Azure, Databricks is a first-party service, which means that it has a lot more support. Unlike other clouds, it's not a marketplace add-on. It's a service provided by Azure. Azure worked very closely with Databricks to incorporate them and provide support for them. So Azure Databricks is integrated seamlessly with Azure services. So you can go to the portal and create it. You can just launch it from the portal. It integrates integrates with Azure Storage Service, Azure Active Directory, Data Warehouse, and Cosmos DB, and also Apache Kafka and HCN sites. Integrates with Azure Billing, so you don't have to pay 2 separate bills. You don't have to log in twice. You don't have to pay separate bills. It's all integrated. And also integrates with Power BI. So it eliminates the need to create a separate account with Databricks. Okay, so this is a typical deployment of Databricks. So the way it works is that you can see the big blue box in the center. It has a collaborative workspace. So if you have worked on any data analytics projects, you know that there's a huge gap between the data engineer, data scientist, and a business analyst. A lot of times what happens is there's some stuff lost in translation. Because of the nature of Databricks, all three, data engineer, data scientist, and business analyst, can all work in the same workspace, which is one of the advantages. And we'll talk about this. I'll walk you through a demo. So you can have multi-stage pipelines. You can deploy production jobs and workflows. You can have job scheduler. You can have notifications and logs. It's optimized for I/O. It runs on Spark. You can call it's serverless and exposes REST API. It's built on all these things. As input, it supports IoT streaming data, cloud storage, data warehouses, or Hadoop storage. And as outputs, it allows you to do machine learning models, BI tools, data exports, or you can also output to data warehouse. So you can process data in Azure Databricks as consumed by a data warehouse or added to a data warehouse. So in many complicated scenarios that we've deployed, we have multiple instances of Azure Databricks at different points in the architecture doing different jobs. So here's what's available. I'm going to skip through this slide really because it's just a landscape of what's available. So you have marketplace technologies such as MapR, Hadoop, etc. available that are IaaS clusters. So in other words, you're deploying VMs with those things installed. You have HCM site, which is built on Hadoop. You have Azure Databricks, and then you also have Azure Data Lakes Analytics. And it all sits on top of either a data lake or Azure Storage. Those are just two flavors of storage available within Azure. And yeah, this is the slide. I'm not going to do the comparison slide. If you guys are interested, what I can do is come back to it, and we can do that towards the end. I'll let you know. Okay, so let's talk about some core concepts in Azure Databricks.
There is a question.
Okay.
Is there any relationship between Databricks and Data Factory?
No. So Databricks is a standalone product, and so is Data Factory. But the nature of Data Factory is such that you can call other endpoints, right? So the endpoints could be that. So let's take a look at it. Data Factory is an ETL tool, and Databricks is a transformational tool. Now, Databricks has Data Factory has introduced this new concept called data flow, and under the hood, a data flow creates an Azure Databricks cluster. But are they related? No, because they could change that data flow to use some other Spark technology, and it would still work the same. So conceptually, they're not connected at all. But yes, in a in a roundabout way, there is a connection. Okay, so we have this concept of Azure Databricks has clusters, workspaces, notebooks, libraries, and jobs. So at this point, I'm going to stop sharing this and see if I can share my desktop. And let me see if I can get it. You guys can still see my screen?
Yes.
Okay, can you see my browser?
Yes.
Okay, perfect. So this is, I don't know if you guys have been in Azure before, but this is an Azure portal. This is what the Databricks space looks like, and this is the Azure portal. So let's start with this. And so when you create an account with Databricks, this is what it's going to look like. You have Azure Databricks, you can go home, and basically home has workplaces, and within workplaces you have users. Okay, so this is a workplace. There's also data. You can create data here. And then you have this thing called cluster, which is where we are. We have jobs. I don't have any jobs. And there are models. So that's what that screen was showing us. Is there's a concept of workspace, which is where you have all your stuff. So you can have multiple workspaces for multiple projects, for instance. Okay, so that's the overarching container for like things. Within a workplace, you can have multiple notebooks, and this is what a notebook looks like. So this is what and we're going to go a little bit more into it. This is where you would create a job. You can actually do a create job, and we'll go through more details as we go. You can have libraries, and you can have clusters. So we talked about clusters, and basically a cluster is a group of machines. The way Databricks and Spark works is that it will stand up Spark machines as needed when you do a job. When you're done with a job, it shuts it down. And that's the strength of this kind of technology, is that it's actually doing parallel processing using many small computers. And when it's done with its job, it'll shut it down. Okay. So those are basically the building blocks. We have workspaces, you have clusters and notebooks. Notebooks is where your code will live. And clusters is where it runs. Libraries are what you want to reference in a notebook, and then you have jobs. Okay. So this is an older reference. This is a benchmark from a couple years ago, and this is how it was. 5 times faster than vanilla Apache Sparks on AWS, 8 times faster than Apache Presto on AWS, and 3 times faster than on-premise Impala via Cloudera. So this is Azure Databricks numbers, and there are updates. I'm sorry I didn't update this slide. And here's a link for the numbers. So what makes Spark fast? This is where we're going to actually look at why it's faster. One of the things that I had mentioned earlier was that it uses in-memory cluster computing. So Spark provides primitives for in-memory cluster computing. And so what happens is that there's a lot of processing that happens on cached data. And as we all know that if we do repeated reads, that's expensive, that's costly. So the diagram here shows the difference between a traditional MapReduce and Spark. So in a MapReduce situation, you would read from an HDFS file system. You would do some processing, then write back, then read again to another process, write again, and so on and so forth. Whereas in Spark, what it'll do is it'll read from HDFS, then it'll keep it in memory and perform multiple steps on it, and then finish, right? The second reason why it's fast is because of Scala integration. Spark integrates into Scala programming language, letting you manipulate distributed data sets like local collections. No need to structure everything as map and reduce operations. So, anyone familiar with Scala? It's functional programming. From ground up, operates on sets, right? Faster data sharing. Data sharing between operations is faster because data is in memory. In traditional Hadoop, data is shared through file system, and Spark stores everything without any replication, in memory without any replication. So why else is Spark fast? So Databricks IO Cache automatically caches remote data on local nodes to accelerate data reads. So we talked a little bit about clusters, right? So this is what's going on behind the scenes. We have Databricks as a platform that has a driver machine that will actually stand up a whole bunch of machines depending on the data size of the job, complexity, and it'll create copies of the local data, and they will be available for each node. And so a copy of the remote file is created for the node's local storage. Currently, the supported file format is Parquet. So remote data is cached automatically, and because of this, each node just never has to go back and fetch the data, even if it's written to disk. And more often than not, it's cached. Okay. So it supports all kinds of storage. Databricks IO Cache lets you enable or disable caching at any time, so you have control. And also cache only a select subset of the data. So you know the kind of problem you're solving, and you can control what to cache and what not to cache. Okay. Also, the cache has to be configured during the cluster creation. Well, that's just information.
We have another question. Is the processing better in Scala than with Python?
Yeah, so the funny thing is, so Scala is ground up a functional programming platform, and the way Databricks will do it is it'll actually interpret, and Python will do sets as well. The thing about it is that Databricks is written in Scala, so that's what makes it faster, and as opposed to just writing your code in Scala. To be honest, I haven't done a side-by-side comparison of the two, but I suspect Scala would be faster. Okay, so I'm going to talk a little bit about machine learning. Actually, this is a good time to look at some demos. So let's actually go ahead and create how to create. So let's say that this is my Azure portal. I've already created one for the demo purposes, but I'll go ahead and show you how easy it is to actually deploy Databricks. So you would go to Analytics and Azure Databricks. And I'm going to call, I'm going to put my phone down, in my hand. And we're going to make it East US because that's where I am. And you'll see that there's multiple tiers One of the advantages of the premium tier is that it has RBAC built into it. For now, I'm going to use this standard tier because this is after all, a demo. Okay, and create. And it's going to take a few minutes to deploy. But in the meantime, what I'm going to do is I'm going to go here. This was deployed earlier today. I created it today. And what it looks like is, there's all kinds of documentation, getting started, how to import data, how to import from storage, all this kind of stuff. But I'm going to launch the workspace, which is where it's going to validate the user. And this is where we are. Okay. I'm also going to be sharing with you guys this Git repository. It's available. It's under Microsoft Learning. It's called Databricks Intro, and it's part of the slide, so you definitely have access to it. And basically, it has 4 labs that walk you through how to, get started, run a job, use streaming data, as well as machine learning. There's a setup guide that walks you through everything, and there's a description of each one of these labs. And the good news is that there is actually data in this zip file, so you don't have to go anywhere to get the data. You can import the data, and you can do all kinds of other things. So, so we saw how easy it was. Let me see, it's still deploying. So to just create Azure Databricks, that's all there is to it. Now I can do all kinds of things, such as I can create a new notebook, I can create a table, I can create a cluster, job, whatever. So the first thing you want to do in Databricks, obviously, is to create a cluster. And the reason for that is because you want somewhere to run your job. So right now my cluster is terminated. The reason it's terminated is because it was inactive for a little bit. So I can always start it, but I'm going to just create a new cluster just for the heck of it. And again, you can have a high concurrency or a standard. For development purposes, I would use standard. I don't have a pool, so I'm not going to use it. So this is the Spark runtime 2.4.5, and it supports Python 3. And it has some autopilot options. Enable autoscaling. So what this will do is it'll ask you how many machines do you want in a cluster. So the default is 2 workers to 8 workers. Now you can increase this as you like, and then also terminate after how many minutes of inactivity. So in my case, I have it at 60. You can have it at 30 or whatever works for you guys. But what it'll do is if it has no activity, it'll shut itself off. And again, there's a couple options here. So there's a whole bunch of different things you can deploy. Now, the general purpose is, as it says, general purpose. There's a HDD version of it. There's a memory optimized. And why do you think memory optimized? Because Spark relies on in-memory stuff. So if you have big data, you may need a higher memory. And also, there's actually compute optimized, GPU optimized, as well as some that are, I don't see any ML ones, but I guess these are it. Yeah, so as you can see, there's a whole bunch of options available. I'm going to go with the standard for right now. Driver type?
I have a question.
What is the question?
How do you decide how many machines require? Is there any guidance on this?
Yeah, so, it is a trial and error thing. The good news is that you can start with as little as 1 machine. So there's always two machines involved. One is a driver, the other one is whatever. The good news is that if it's not a huge job, it won't deploy all the data. So in other words, basically this is a big data processing problem, correct? So if you upload a file that's a megabyte, it's not going to start all 8 workers because it knows that the optimal size to process is not going to be like 10K or whatever, right? So so it's not dumb that way. Now, if you have huge data, then you want max workers to be high. And there's going to have to be some trial and error in that, okay? So there's this advanced option. In the advanced option, there's Spark config. And this is where you would put any configuration parameters, such as you might need to connect to a storage, either Azure storage or whatever other, right? I'm going to cancel this and not create it. I'm going to show you what this configuration looks like. So, so it has a driver type. So again, the driver is the one, it's like the central command that decides how many workers to spin up or not. And then the workers, I have 1 to 2 because this is a demo, and I have it terminate after 60 minutes. Here's an example of, this is just a key to access my storage device. You can copy it, but I'm going to delete it as soon as we are done with this. So I don't mind sharing this with you guys. So that's where it is. So that's what a cluster is for. Now let's take a look at the next thing, which is a notebook. So I'm going to show here, there's a few notebooks here. There's one, which is just a getting started. There's one on data frames and another one on machine learning. So here's an example. Let me go back to my Azure subscription. And if I go here, you'll see that, actually, I refresh that. Yeah, there's 2 of them. One I just created, but this one is the older one that I created earlier. What I did was I actually created a storage, and under the storage, I created a container called Spark. And under Spark, I have some data. All this data is available in that GitHub repository, so this is not new data, okay? And so there's a Kennedy inaugural speech, and then there's a couple CSV files, okay? The reason why I'm showing you this is that we're going to be referencing this in our notebooks. So here's my test Kennedy inauguration notebook. So this is what a notebook looks like. It's really neat because each command is different. So this one is just a text command. You can't execute it. This one is a cell, and what it does is, and this is Python by the way, it will open a file called Kennedy inaugural, and then it'll tell you how many lines of it. So let's run it. My cluster was stopped, so it asked me, hey, do you want me to start your cluster? And I said yes. And as you can see, that I've actually run this before because I needed to make sure it worked for tonight's session. I'll take a second. Now, so the thing about Spark jobs is that they do have, they take a minute to start. So somebody asked about ADF. ADF allows you to have copy pipelines or data flow. The difference is that data flow takes a few minutes to start because it's starting a Spark cluster in the background. So there's a cost involved with that. Once the cluster is up, then things get super fast.
There is a question if a notebook is similar to Jupyter Notebook.
Absolutely, yes. So this is just Jupyter Notebook. I haven't found any differences between the two. Scala command in another, and a Python command in the third cell, and it all works. It's magic. So I love notebooks, and Databricks embraces notebooks. And this may come back eventually. Let's look at this cluster. Waiting for cluster to start. Yeah, I should have started my cluster before the demo started, huh?
What would you recommend for a small startup business when it comes to storing and sharing files? What's best, yet not too much?
So, yeah, storage is the cheapest thing that, okay, so it ran. Well, no, it didn't run. Storage is the cheapest thing you can buy on cloud. And basically, whether I work for Microsoft, so I'm going to recommend Azure storage, of course. But basically, it's the cheapest thing you can buy on any cloud. What you do with the storage is a completely different thing now, right? So storage is pretty cheap. Whatever is comfortable, you feel comfortable with, is what I would recommend you going with. Now storage comes in many flavors, right? Okay, so here we go. It ran. It took 4.03 seconds to run this, and let's see. Let's see what it did. Come on. Doesn't want to move. Okay. So here's what it did. It created a pool. It read the file, loaded it, which took 3 seconds, and then it did the count. So do this, and it says there's 44 items in this one. Let's run this one, which is text up first. So now that it's loaded in this notebook, it's available to us, and also the cluster is up, so this should be faster. Okay, so it comes out, it says 0.24 seconds, Vice President Johnson, Mr. Speaker, this is the beginning, this is the first line. And here, what we're doing is we're looking for every line that contains the word freedom. So we're gonna run this. And it says there are 4 lines. And in this one, it's actually going to tell us what line it is. So there it is. And these are the 4 lines. So here's an array. You can see the square brackets. And then there's comma-separated strings in there. So that's string number 1, string number 2, string number 3, and string number 4. So, and then you can do fun things like count all the words. So this is more of a, doing something with the text, right? So this is saying, hey, there are 83 does, 66 of, 37 twos, 36 ands, 29 a's, and so forth and so forth. Okay. So this is a very simple notebook, just showing you what's going on. You can schedule to run this. You can say, hey, create a new job and run this every hour. I don't know why you would do that. This is how you would create a job. So let's just say that we're going to do it. And then let's go see. Now we have a job. And basically it'll run this capsule every hour. I'm going to go ahead and delete this job because it's kind of silly. Now, you wouldn't want to create a job like this. If you're doing something like, hey, read files from a location and then process it and put it somewhere else, that makes more sense to do it repeatedly. Okay? All right, I'm going to stop with the demo. Any questions about this?
Yes, we have questions about clusters.
Okay.
the first one. Is there any way clusters are related?
I don't understand that question. So I'm assuming that, do you think that the clusters speak to each other? Is that what you're talking about? So basically what happens is all communication happens through the driver. So clusters, what happens is when you define a cluster, let's say that I defined a cluster of minimum 2 machines, maximum 100 machines. First of all, they're all have the same configuration, right? So that's how they could be related. If the question is, do they communicate with each other? The answer is no. Because the whole point of big data is that you're doing parallel processing, and the driver actually will be the one that's coordinating each one of the jobs. And once the job is done, then it'll do whatever. If you have 15 steps, then it'll do 15 steps. If they need to coalesce, so in kind of like a workflow where you have split and merge, that'll happen on a different machine. If that makes sense. Okay.
Perfect. Then there is
any other?
Yes.
Yeah.
We have one that says, whenever you bring your data over to, let's say, a data frame, is the driver the one that normally partitions the data?
Yeah, the driver is responsible for partitioning the data. So if you actually run a Spark job, you'll see the parting files being created and then consumed. Now, if it's a connected source, such as like a large, if it's a connected source, then even the ingestion can be given to the machines. So that could be a job itself, right? So it depends on the code. So if your code is to take a massive file and split it into equal whatever files, then that could be a Spark job as well. But yeah, but the data frame, when you load, so let me go back to my screen. So actually, let me do this. There's a data frame example, right? So here, when we're saying, hey, text file, do this, and then print schema, if we run this, so again, this is using data frame, not RDD. The previous example was using RDD. This is a large file, so it's going to take a little longer.
There is another question. I thought you have created jobs in the notebook, but there is a separate configuration to create the jobs in Portal. Bit confused.
What do you mean portal? Is it Azure portal? So yeah, I mean, in the back end, this is a cron job, right? So yes, there's 2 ways to create a cron job. You could also drop into the actual physical server and create a cron job. It doesn't matter, it's a cron job, right? So so let's take a look at it. Yeah, so as you saw that it took a long time, and the reason is because it was actually consuming, loading the file, and it's just one node. So yeah, you can do the jobs through here, create a job, and it'll ask you, what the job is, or you can go to the notebook and create a job through there. Schedule. So it's just, I mean, it's the same thing. You can actually, here's the cron syntax, right? The only difference is that when you do it from here, you can say, hey, run this notebook or whatever, right? Test. And you can either select a notebook here, or you can select a library, right? A jar file, or you can create a command that does a submission to So it's the same difference. Okay?
Mm-hmm.
But yeah, at the end of the day, it's just creating a cron job. All right. Any more questions?
Yes, we have some. Where can you start the cluster before you run the code?
Okay, let's go back. So you go to cluster, and you can go here. You can it's running right now, or this would say start. Okay, you can restart, you can edit, you can clone, delete. Also in the clusters view, there's a stop, restart. So right now it's stopped. I can start it here. And it says, you sure you want to do this? Yeah. I'm confusing it. Any more questions?
Yes.
How outputs from different jobs will be combined in the result set?
Yeah, so there's syntax for all of that. So if you actually look at the notebook, and just so you know that it's not just through notebooks that you can run things, you can also run libraries or something like that. So for instance, here we loaded something in text, and then we're referencing txt dot, and then here's FLT text, right? Filter text. So you could also reference text here, right? You could combine, you could do join, you could transform, you could do all kinds of stuff. The samples that we're showing here are very, very basic, but there are better examples out there, and so there's a whole bunch of syntax. Let's take a look at the machine learning notebook. So this is loading flights from a file, and this one is actually removing duplicates. I wonder if it's... No, this one is not doing any combines, but this is the other thing, is that you can look at any output either as a table, or you could look at it as a job, a bar chart, which is kind of neat. And you can also download the results CSV. So notice the syntax. This is where it's saying, hey, the statement after this is not a Python statement. It's actually a SQL statement. That's what's neat about notebooks. So very much like cheaper notebooks. Okay. Yeah, I don't have any combined examples. I'm sorry, but I'll make sure that I include that in my list. Any more questions?
Do we need to be well versed with Python to work on this?
So two things, right? The basic stuff is simple, so no. And as soon as you start doing anything useful, yes. So you can wing it for the original, the original part, have fun just playing with it. And Python is very, it's an easy language to learn. But yeah, no, as soon as you get into the data science part of it, then it starts getting complicated. The good news is that you can do Spark SQL right off, right? So you can do that. A lot of people that I know that are data people that are really not coders will do like 90% of their notebooks are SQL, and then there's a little bit of Python, and they're definitely not Python experts, but they're still able to do a lot of stuff. But then you have the data science geeks that will be writing Scala over here and Python. So, but Python is good to know. It's not that complicated to learn. Okay, so I'm going to talk a little bit about Spark machine learning. It again, it enables parallel distributed ML for large data sets and Spark clusters. So as you can see, the advantage is the architecture of MPP, right? Massive parallel processing. So because of the parallel processing, you can do machine learning faster as well. So it supports things like model selection. So what is model selection? If given a set of models that are similar, right, you can have different algorithms that are very close, but they're optimized for specific situations. It'll actually use the most efficient one. So it does model selection, which is kind of nice. It does things like cross-validation, train validation split. So anybody who's taken any class in, neural networks, you know that what you want to do is you want to train with some of the data and then test with the smaller set of data. So if you have a ton of data, you have a model, you train with, say, 80% of it, and don't quote me on that, it depends on the situation, right? And then you take the 20% to test it to see, hey, how good is my model that I trained using the 80% of the data? And then you can do validation based on, data that you know the results of. So supports Java, Scala, Python, using data frames. So one of the advantages, and I don't know if we talk about this or not, is that it introduced this thing called data frame. So it doesn't matter where you're importing data from. And I showed you examples of a text file and a CSV file. What it'll do is when you load it, it becomes quote unquote a data frame, which is sort of a standard API. So it doesn't matter where your data came from, all your queries will reference the data frame, and so you're coding against a like type. And one of the advantages is that it actually, data frame supports unstructured data. So it'll pretend that it's structured data even though it's unstructured. So it has a uniform API across ML algorithms and across multiple languages. Facilitates pipelines. So pipelines are where you can chain algorithms. So one person asked about how to do like split or whatever. So that's how you would do it. ML pipelines allow you to do step 1 is do X with the data. Step 2 is split it into 500. Step 3 is join it or whatever. So I'm making this up, but that's what it looks like. Spark MLlib comes pre-installed with Azure Databricks, and it supports a whole bunch of third-party libraries. This is just a tiny subset. Microsoft Machine Learning Library for APACHE SPARK lets you easily create scalable machine learning models for large data sets. Includes Spark ML pipelines with the Microsoft Cognitive Toolkit. So I don't know if you have used it or not, but the Cognitive Toolkit is really neat because the models are already made and constantly being improved. So all you have to do is you just use it. You don't have to train data. You don't have to do anything. And so, and again, if you don't know, cognitive services are things like image recognition, natural language processing, just things like that. So those are things that a lot of us need. So let's say that we're writing, I'll give you an example. This is a real life example, no company names. One of the things that an HR department wanted to do was they wanted to look at the exit interviews of everyone that quit the company to figure out why they were leaving. And one of the things that you can do with cognitive services and natural language programming is to find out if the person was angry, happy, or neutral, or whatever, disappointed. So it actually would give you a score of, hey, there's a 70% likelihood that this person is upset or angry. And that gave them, some analysis of, okay, what pattern of people are leaving because they're angry and so on and so forth. So that's an example of cognitive services. Ingress and pre-process image data. So that's part of the cognitive toolkit, featuring images and text using pre-trained deep learning models. And so, their models keep improving because they train it all the time. Train and score classification and regression models using implicit featureization. If you're not a data scientist, that sentence is not going to make that much sense to you. But, features are important when you're doing models.
We have a question to Spark. Do we need to move it to Azure storage?
So here's the thing. Spark is the compute engine. So it's a platform compute engine. It has connectors for all kinds of things. So you can consume data from, and we went through this a few slides ago. You can either consume from a stream, you can consume from a storage, which could be Azure storage, or it could be a data lake, or you could have something like a data warehouse sending you data, and so on. So there's a few ways it'll consume data, and then it'll transform and put it wherever you want it. So wherever you want it could be, and again, it could read from SQL or whatever, some database also. So that's the ingress part. It doesn't have to use storage, but in our example, we're using storage. So here's some of the categories of algorithms. You have classification and regression, you have clustering, collaborative filtering, dimensionality reduction, frequent pattern mining, and basic statistics. So classification and regression, easy, right? You want to process like pictures and see, whatever, male versus female, whatever, things like that. Is it a fruit or a box, or I don't know. So classification. Clearly, I'm simplifying it, but it's a lot more complicated by that. We have models that can read shelf labels and decide expiration dates and ingredients and all kinds of stuff. So example, one of the clients was a oil drilling company, and they have data coming in from a camera mounted on the drill bit, such that it'll actually sense the hardness of the strata in front of the drill bit, and if it's too hard for the drill bit, it'll adjust the trajectory of the bit to go around it. And this ended up saving all kinds of money for this company. Similar with air conditioning, sensor data classification. Is it good, bad, tepid? If it's tepid, that means that there's a breakdown about to happen, and so they send repair people to preempt any issues. So saving money. Clustering, exactly what it sounds like. Throw a bunch of data, see what kind of clusters happen, and decide, what pattern is emerging out of the cluster, right? So if there's clustering happening in a certain pattern, that tells you a lot about your data. Collaborative filter. I'm not going to go over all of this because there's this is more data science than Databricks. Let's talk about a couple of the use cases. So I talked about Lennox. Lennox is, they're air conditioning, heating, air conditioning, refrigeration company. And so they use IoT devices in all their machines. And with Databricks, they moved from 60% accuracy to 94% accuracy on detecting equipment failure, which really helps them save a bundle. Because if you get to it before it dies, then there's a lot of advantage to that. So in our previous process, 15 devices, which created 2 million records, took 6 hours to process with Azure Databricks. They were able to process 25,000 devices, 10 billion records in under 14 minutes. So this is the reviewable. Here's a company out of the UK that uses solar power. They're solar power producers, and they needed to predict when they will generate electricity so that distribution could be handled. And so this is predictive analysis that they did, and we have been doing demos, but I'll go back to it. Yeah, I don't like doing demos right at the end because of the fact that it makes more sense sometimes to see the screen than to do it. So.
We have a question. Is Linux using ML?
Yeah, so of course it does, because what it does is that the IoT devices are streaming data, right? So IoT devices always stream. So you collect the streaming data, you run it through already created models to find out, hey, does the data indicate issues with the system, right? If it does, then there's an alert or whatever, and then what happens is that data is now added to the training data so that the model can be enhanced. So it's a feedback loop. So it's kind of like saying, hey, if I train, raising a small child, right? If I show, I remember the story. My daughter, we had a dog, and she was very tiny. She could barely speak. We were out for a walk, and there was another dog, and my dog was this huge dog, and she looked at the other dog and goes, "Doggy," and I was like, oh my God, my daughter is so intelligent. She can tell species of animals. But then 2 days later, we ran into a person carrying another baby, and she goes, "Doggy," and I was like, okay, yeah, she's maybe not that smart. She was just a child, but so the more data you give a neural network, the smarter it gets. So there are two parts to every one of these deployed architecture. One is the original data that you train the model with so that the model can do prediction. And then the second is that any data that you're collecting after that, you feed it back into the training. And so what will happen is over time, the model becomes hardened, or in other words, it's more accurate because it has more data now to learn from. And so yes, it's using machine learning to do predictions, because otherwise, yeah.
There is another question. How can we pull data from on-prem log systems?
Good question there. So what you would do in a case like that is you would first put it in a data store, whatever, Azure or something like that. And then you would consume it from Databricks. Now, the other option is you could run Databricks on-prem, right? It's it's not recommended at all. The third way to do it is, let's say that, hey, you have a system on-prem that is very chatty, right? It's got tons of data, and you don't want to put it somewhere and then have the Databricks consume it. You could set up an express route between your on-prem gateway and Azure, and then the Databricks can consume it. You can make it available to Databricks using UNC, and you can access it directly. I don't recommend that because it's probably going to be a little slower to consume. And remember that you want the environment to run for as little as possible. We talk about storage being the cheapest thing that we do, and any cloud does, and compute being one of the more expensive ones. So what you want to do is you want to minimize compute time. You don't want to spin up a cluster, then take all your time moving data, waiting for data to get there before you start using the cluster, right? So that's one of the suggestions I would make. And it depends. And you could have a very unique circumstance where that makes sense to you. Any more questions?
Yes, there is a question but it's more broad. We can make a whole webinar about this.
Are cloud platforms like Azure less secure from hackers or data thieves than having that same data on hardware storage?
Yeah. So Azure has like certifications from all kinds of places. You know, I get this a lot. There's a lot of people who are like, oh, you know, the data's better in my data center because my data center is the best. Well, it's kind of like saying that, hey, the money is safer under my mattress than the bank. Yeah, the banks get robbed, but the thing is that chances of it, you know, getting destroyed under your mattress is higher than the bank. But the point also is, so Azure data centers are physically highly secure, right? They are actually, Dell makes the hardware for Azure. Again, like Cecilia said, it's a whole different ballgame.
Yeah, a great topic.
The whole data center is like one block, and they just fly it and drop it in place and hook up electricity and the cooling, and boom, it starts, and internet, and it starts. Everything is segregated a lot, and you know, we have government clouds and we have government data on Azure, which is a separate cloud. But the point is that it's got all these certifications, and they constantly audit and they constantly monitor. So you know, they have more expertise in data security than the person, you know, especially, you know, I get this question from small businesses, and it's like, really, you're going to hire somebody who has more expertise than Azure? Not going to happen. You can't afford that person. So, you know, for an enterprise, it's a valid question. And for enterprise clients that are very, you know, they're doing highly sensitive data, they're concerned about, you know, the quality of their data, they need to keep their users separate. And there's a whole like security stuff that we can do about it. And there's ways to do it that makes it more secure on the cloud. You could keep, you know, you could put it on a storage that has public access, and then of course it's less secure. But that's you not taking advantage of the infrastructure that's built. Here's some references. So this is the Renewable AI Power Utilities reference. This is the link to the Microsoft Learning. So there's two links here. GitHub.com, Microsoft Learning, Databricks Intro, and Databricks ML are amazing places to go start. I think I already showed you the GitHub repository for Databricks Intro. All the notebooks that I was sharing with you guys today was from that repository. The ML repository has a little more complicated stuff. I don't have those notebooks imported, but you can certainly go there. They have step-by-step instruction, even if you've never used Databricks, and I promise you, you can get it done and you can get going. Also, docs.microsoft.com, go to Azure Databricks, has all kinds of information on it. So, and finally, we are on the question slide. So,
and we answer all the questions.
Yeah, I'll take more questions if there are any.
We have one here. Is there any integration with Azure Confidential Computing to protect data in memory?
So because the Spark clusters are isolated, there's no way to address it. So you won't be able to sort of hack it or anything like that. But basically there are VNets, so you know you would really have to like there's no addressable way of getting to it. But it is Databricks infrastructure. So what I'll do is I'll send you some additional materials that have to do with security, because it seems to be like a question. Mm-hmm. But yeah, so even I cannot like I can't go look at, you know, the actual machine that are stood up behind the scenes. So, unlike on-prem where I can just do it.
There we go. So yes, we reached the final. We made it. So I would like to thank Barkha and thank everyone, especially for the patience with the microphone issue. And well, stay tuned for our next webinar.